live? Hi, I'm Tim Van Milligan. We're here at RockSim Live. It's live on YouTube and it's Friday, October 29th at 2 p.m. Mountain Time. It's 4 p.m. on the East Coast. Thank you for joining us. This is where we talk about designing model rockets using the RockSim software. As I said, my name is Tim Van Milligan. I run Apogee components, and let me show you my screen, and I'll show you a little bit about RockSim so we can get started. If you're new here, go ahead and over here I got a monitor. That's kind of why I'm looking over here. Go ahead and type your name and where you're from so that we can recognize you. It's so cool that we have people that show up every week, and new people are joining on live as we're talking, which is great. So welcome everybody. Let me show you my screen. So here is my screen. This is the Apogee website. We record these RockSim Lives and we archive them on our website. And to get to them, on our website, apogeerockets.com, go to How To and Guides, click on that. Come down here to software, click on software, and then over here is RockSim Live Training. That will get you to this page here that I'm currently on. Oops, come on, go away. RockSim Live Training, and it has the archives of all the videos that we've done. So far, we're on episode number 42 as of today. This tells you, the link to the previous one, plus all the topics that we talked about, and the timestamps of those topics so that you can find them really quick. I always like to point this out because there's so much information on this page, because we've been talking about this now since, when the first one was. It was January 15th, 2021. And it's now October 29th, so we've been going every week. I haven't been here every week, but maybe you have. We've had Michelle fill in for me when I've been on vacation or out doing other things. We got Nick Verini in here from Colorado, Michael O'Brien from Mesa, Arizona. Clint Browning says, got my engine retainer in painting my rocket now, only the best parts from Apogee. So great, Clint. Glad to hear that. Clint is from North Carolina. If you have a question on how to use RockSim, that's what we're here to discuss. You control what I talk about. Like, I'm your little sock puppet. I'm going to talk about what you want me to talk about. So if you have a question, go ahead and put it in the comments. And if you're watching this later on YouTube, go to the Apogee website and just go to our contact form. And here on our website, always at the very top, on the very top right, is our contact form. So if you scroll down here, you can go to the contact form. That brings you to this page. And this is a drop-down menu for send email to. So if you click on that, you can do, RockSim general questions. You can put those there. If you'd like to beta test the launch visualizer, use that one. The launch visualizer, since I mentioned it, I better show it because otherwise you're going to be confused about what it does. Let me open up a new browser window here. The launch visualizer is on a special website, and it's called rocksim.com. So I just have a shortcut here. Just click on that, and that brings you to our launch visualizer. And this is what it looks like. It allows you to run simulations like RockSim, but it's all online, so there's no software to download. And it's all in 3 dimensions. It runs 6 degree of freedom simulations. So it's like, we're still in beta testing right now, so we're not taking any money for it. So if you want to use it, and you want to use all the features, you got to contact us, and that's where that contact form comes in. So make sure you do that. It's a lot of fun. It's like the more I use it, the more I'm thrilled about it, and I'm sure the more you use it, you're gonna experience the same thing. It's just so much fun. So we got a couple of questions here. Oh, we got somebody from Poland here today. That's awesome, and in Canada, in Ottawa. Rosa from Ottawa, Canada. Okay, not Ron, not me, which is Carlos. He says, when making your own body tubes with a wrapped mandrel or a female mold, does RockSim need only the weight, CG, dimensions, or do we need a material density guess? Is that density derivable? That is his second question, which is pretty easy to answer. The first one was, can RockSim be used to analyze short duration weights or drags like piston launchers or umbilicals that detach as the rocket rises? Short duration weights or piston launchers. Okay, piston launchers and short duration weights that detach as the rocket rises are two different things. A piston launcher imparts extra velocity to the rocket. That's used in competition rockets because you want to get as much energy out of the launch as you can. And so the way a piston launcher works, let me see if I can find you a piston launcher on our website. We used to sell them, but the manufacturer has discontinued them. Piston launcher. No, I don't have one there. Let me go to the newsletter section. So go to the newsletter, go to Picaflight newsletter right here. Go to all newsletters so that you can see all of them, so we can search in all of them. And this is the page. We're on coming close to issue 560, which will be in 2 weeks. I'm going to do a find on this page, and I'm going to cite piston. Comparison of piston launcher technology in issue number 428. That brings up this image. Okay, and here is my daughter, and she's using a piston launcher to launch a rocket. She's going to launch a collider off of a piston launcher. You have a piston head, which are those, and you have the piston tube, which captures the gas. Trying to find a picture of it all put together. So here's the tube, here's the piston head, the igniter goes inside of that, and that slides up onto the base of the rocket engine, and it goes around the outside of the engine, so you can't use a rocket that has an engine clip because that would get in the way. So, but it has to go over the top of the engine, and as the engine ignites, all that gas is captured in that piston tube, and it pressurizes the bottom of the motor, and it just kicks it up into the air. And you could probably get another 5% in altitude from that. It doesn't sound like a lot, but when you're in competition, every little bit helps. So that's one thing. And then things that fall off the rocket on the way up is something completely different. So to model a piston launcher, you have to you got to trick RockSim, because there's no way to say, I want 5% more thrust out of my engine using RockSim. It just doesn't happen that way. So you got to create a special engine file. So I'm going to go engine edit. Okay, so this is the old version of engine edit, but I'll just use this one. I'm going to open up like an Estes motor, okay? Okay, and it's not finding it, so I got to go to application. Yeah, first I gotta go here to my Go menu, and I gotta go to library. application support, and then come down here to RockSim. So I'm scrolling down to RockSim, or no, I got to go to Apogee components. Apogee components. Okay, so the data for RockSim is stored in the RockSim_1, and in there is the data folder, and in the data folder is all the engine files plus all the parts files. But I'm looking for the Estes engine files, so I'm going to go, here's my Estes engine files. I'm going to duplicate that because I don't want to override it. Duplicate. So now I got a copy, and okay, so now I need to open that. And it's asking me which application to open it. And let me go to my application. Now, I'm being very convoluted right here, but basically I'm trying to find engine edit so I can open this file in engine edit. I know the best thing to do is here in this data folder, I'm going to take this file, just throw it on my desktop. Okay, so it's on my desktop. And now from engine edit, I can go to file, open, and just point to my desktop, because this other file that I was looking for was a hidden file. So desktop. Okay, so here it is, Estes copy. Open that. Okay, so I'm going to take like typically in competition you're using small motors like 13 millimeters, so half A's and A's. So an A3 would be a common motor. And this is, let me see if you can see that on my screen here. Okay, so you can. Okay, so this is the thrust curve of the the A3T motor. So I'm going to take that motor. I'm going to delete everything else in this list. So I'm going to highlight it and just go delete and say yes. I'm going to have to do this for all the motors, so it's going to take me a couple of seconds here. Because I want to create just one special motor, and that's my goal here. I'll leave, yeah, I'll delete that one. Why not? I'm going to do the A3. Delete. Okay, so there's the A3. So delete. Okay, so my file called estescopy.rse only contains one motor right now. It's the A3. And here's the thrust curve down here of this A3 motor. And like what I said before was that a piston launcher will give a higher kick to the motor right as it comes off the piston. So the duration of that piston effect is very, very short. It's like probably less than 0.2 seconds. So what I'm going to do is take this data point right there. Let me change my colors. So selected point color, I'll make this red so you can see what I'm doing. Click OK. Okay, so this point right there, it's in red. And I'm going to take that point and I'm going to bump it up maybe 5%. This is the thing that we don't know, is actually how much thrust does it impart. But I'm going to take it, I'm going to move it up here to like 7 newtons. I'm going to take all these other ones and bump those up as well, right before this peak point. Because at this peak point, I'm saying that it's leaving the piston. And after it leaves the piston, then the only force that we got is what's coming out of the motor. So then the thrust curve would be normal. So I'm taking all these points and just, oops. I want to take them and bump them up a wee little bit. I keep adding points, but you get the point. So now my total impulse on this motor has gone up. because I have changed the thrust. See, every time I move that point up, my total impulse goes up. Okay, so I'm probably not moving it up high enough because I think I want a little bit more thrust. Okay, so when I got it to where I want it, now I want to save it. So now I'm going to do File, Save. I'm going to do a Save As, and I'm going to call it, I want to put it on my desktop, and I want to call it the Estes, let's call it A3 piston. A3 piston. Okay, so, and then I'm going to make it an RSE file, and it's going to be stored on my desktop. I hit save. Okay, so now it's on my desktop. So now we got this motor, and we want to run a simulation to simulate a piston launcher. So let's open a rocket that is a 13mm engine mount. So I need something small. So let's see, Apogee Designs. Just looking in here. Okay, so here's the Midge rocket from Apogee, and I know this is a 13mm. Oh, and it's actually a 2-stage rocket. Okay, so it's this is a payload altitude rocket. So inside of here, you'd put a payload, which weighs 1 ounce, or about 28 grams. Plus, you put an altimeter in it to measure the altitude, and then you launch it as high as you can. This is a good event to use a piston launcher. And this one designed as a 2-stage, but we can fly it as a single stage. Okay, so we want to fly this comparing an A3 versus an A3 with a piston on it. So first I got to load that piston motor into the database. So to do that, I go to File. I'm going to do Import Engine Files right here. Okay, so now it's looking for a engine to import. So I remember I saved it on my desktop. And there it is, A3 piston.rse. So I'm going to say open there. And it imported it, and then it copied into my database folder. Click OK. And here it is on this side, and we need to move it over to the right side so that RockSim will see it. So I'm just going to click Add. And it added that engine file to my database. And I also have the Estes files right here, which has the regular A3. So I'll click OK on that. Now we will run a simulation. I'm not going to put anything in the booster stage. I'm only going to put it in the upper stage. So first let's choose an engine. And we'll choose the A3. Where's my A3 piston? Click OK. Let's put a 4-second delay on that. Let's 800 starting state 36, launching straight up. I'm just seeing what I've got here. 8-mile-an-hour wind. Okay, let's do a flight profile and see what that looks like. Okay, so here's the rocket down here. When we launch it, rocket takes off, goes up, and pops out the parachute right there at the top. Okay, that flight looked good. That's all I was looking for, just to make sure it looked good. And it gives us an altitude of 308 feet. Now, I want to load that A3 piston into that tube. You know what? I think I did something wrong. It's like, why am I not seeing that motor? I should have 2 A3s here, but when I was in Engine Edit, what I forgot to do was to change the name here. So I got 2 engines with the same name, and it's probably confusing it. So let's call it A3 piston. And hit save. Okay, so it saved it. Now I've got to reload that motor. Okay, so what I'm going to do here is I'm going to delete it out of my database. So I left this window open that has all my engine files in it. And you can see when I imported it, it moved it into this folder. It took it from the desktop, moved it into this folder. Now I'm just going to take it out of this folder by deleting it. So I'm going to hit Command Delete. And I sent it to the trash. Now I should still have it on my desktop. Okay, so here's the new one on my desktop that we just saved. So I'm going to go cancel out of here, cancel out of here. I'm going to go to File again, Reload Engine Data. Oops, I didn't want that one. I wanted to import. File, Import, Engine Files. Go to my desktop because that's where I stored it. There it is. Click Open. It imported it. I put it over here. Okay, let's cross our fingers and hope that it worked, because it should have been over here. And click OK. All right, so now let's load that piston. Let's cross our fingers that it's there. Choose engine. There it is, right there. A3 piston. The original A3 had an impulse of 2.22 Newton seconds, and our new one has 2.46 Newton seconds. So click OK, because we're going to load it. And then we're just going to do launch, just like we did before. And what the only thing that we need to do is to compare the altitudes. And the altitudes are exact. They should have been different. So what happened? Let me try something different here. Let me load this engine. On flight events, no, I did have it deployed Apogee. So I guess we're not just seeing enough kick coming off the launch pad. It should have been a little bit different because it's two different motors, and one has more impulse than the other. So that's how it should work. It's not working for me right now because it's probably because I didn't bump it up quite enough. Not enough total impulse difference. That's what my thinking is, unless there's something else that I'm missing. Okay. We got more people. L. Anzik says, made it. L. Anzik is from Colorado Springs, so that's cool. We have ESPN 8. He says, hi. Michael O'Brien says, just purchased RockSim. Now I will really pay attention to these sessions. Cool, Michael. And Joseph Dunning says, hello from Alamogordo, New Mexico. Yeah, I love Alamogordo. I've been there many, many times. Okay, so we've answered the question on piston launchers. Now, his other question is, what happens, can you drop things off the rocket as the rocket's going up? The answer here is you have to trick RockSim, and it's going to involve pods, because pods are the only thing that can fall off of a rocket in flight other than booster stages. So if you create a pod that would mimic your short duration weights, then you could do it. So how do you do a pod to mimic a short duration weight? So something's going to fall off your rocket. An example might be flyaway rail guides. So I'm going back here to the Apogee website. Flyaway rail guide. It doesn't matter which one. Okay, so here's a flyaway rail guide. This is what it looks like, but how it is used is it fits around the rocket like so, and you use it in a rail launcher, And as the rocket goes up, it captures, you know, the rail goes on these little teeth to capture it. It's like a, yeah, so here's a launch rail, and the flyaway rail guide fits inside of that. And so the rocket is captured and it goes up with the rocket. And when it hits the top of the rail guide, the flyaway rail guides open up and then fall off. So you're carrying part of the weight upwards, and then finally it falls off. Let's see if I got a picture. So they're activated by rubber bands. This is something that I came up with a long time ago. Here's a long rocket with two flyaway rail guides. There's one up here and there's one on here, and behind here is the launch rail. And the launch rail probably only goes up to about right there on this big rocket. And then when rocket takes off, so it's taking off, and you can see the rail behind. And you see this one is detached already, so it flies away from the rocket. This one is still on the rail, so it's still attached. And then when it leaves the pad, it falls off too. And the second one is actually higher than the first one, because the first one, the rocket wasn't moving very fast when it flipped off, so it just flipped off and fell away, where the second one has some momentum. So the momentum carries it a little bit higher, and then it fell off. And then when they land pretty close to the pad. So that's what a flyaway rail guide does. So we need to try to mimic that. Okay, so that's, to do this, you're not only going to need a pod on your rocket, you're going to need a special rocket engine for your pod. You need to create an engine. If you put an engine in a rocket, that engine has weight. So we need to create, the reason we need to use an engine is because the engine determines when the pod falls off. So if you want something to fall off at 0.1 seconds in the flight, we need an engine that burns for 0.1 seconds and then falls off. But the engine can't have any weight, and it can't have any propellant weight. So this is where it gets complex. I use fake engines occasionally. So we're going to make a fake engine. And again, we're going to go here to Engine Edit. And we're going to create a fake engine. So I'm going to add, okay, so I'm going to delete this engine. Say yes. I'm going to add a new engine. Okay, so now my fake engine, like I say, I want this one to burn really short, like 0.1 second. What I'm doing here is like super ultra advanced. So if you're Michael O'Brien, if you're just learning RockSim, I hope I'm not making this too complex. But this is for the advanced user. You know, we're trying to trick RockSim into doing something it wasn't really meant to do, because it's really hard to drop things off the rocket that affect the flight. Then we need some kind of triggering event. And I'm scratching my head because I'm thinking, is there another way to do this without using a fake engine? In RockSim, probably not. In RockSim Pro, there might be, and we could explore that. Anyway, so let's get back to creating a fake engine. So my new engine, it's going to burn for 0.1 seconds. So we'll make it a really short duration, and we're going to give it a thrust of, I don't want it to have any thrust, but I got to give it some thrust. So I'm going to give it a total peak thrust of 1 Newton. And what that's going to do is it's going to draw a graph down here when I click OK. And the high point, well, the midpoint is 0.1 newtons. And the burn time here is 0.1 seconds. And so I'm going to click one point here. Like we already specified this point when we set the duration. And then this point here is the variable one, and I can move it around. And I can make it as small as I can so that the rocket hardly has any thrust at all. So I need to give it a manufacturer name, and I'm going to make it an Apogee motor, and I'm going to call it fake motor. And it's a single use, and there'll be a 0-second delay. And I'll make it a 13 millimeter motor, and the length, I don't know, the length 70 millimeters is, I think, is a common engine size. Okay, so now here is the mass. Okay, so these numbers up here don't really affect it. It's just kind of for our drawing purposes in RockSim, so you can kind of see it. So the initial mass, I gotta give it some mass, because if I don't give it any mass, RockSim is just gonna blow up. But as long as the mass is like wafer thin, it can trick RockSim. But if it's so small that it's incontestable anyway, it's not going to affect the flight. So we're going to give it a small mass. I'm going to call it 0.001 grams. It's kind of like one little tiny grain of black powder. And then the mass, we'll call it 0.002 grams. So it hardly has any weight. And oops, I did these backwards. This one should have been 0.2, and this one should have put 0.1. So it hardly has any weight at all. I mean, you couldn't measure this on a scale. And I'm going to put a comment in here for doing weird simulations. I need a fake motor. I just need a motor that will trigger something falling off the rocket. Okay, so if I like it, I can save it. So I'm going to do a file save as. I'm going to put it on my desktop again. This time I'm going to call it my fake engine. .rsc, save it. I'm going to make it a RockSim file. Save it. Unable to write data, fake read only file system. What is that? Save as. So something's wrong. It doesn't like something. File save. Let's try saving it as a .eng. Oh, I was saving it in the wrong spot maybe. Save. Okay. So it saved it. Okay, so now I have a fake engine. Let's load it into RockSim. Import engine files. It's on my desktop. Where is it? It should be called fake.rsc. Oh, here it is. Let me go back there and resave it. Fake file save as desktop. Let's see, I didn't change that name. Fake and .rsc save. Okay, it saved it. Now let's go here to file, import engine files, desktop. There it is, fake. Click open. It imported it. Okay, so we're going to take the fake and move it over to this side and click add. Click OK. Okay, so that engine should be in here. So let's load it into this rocket just to see that it's there. So choose engine. There it is, Apogee fake. 0-second delay. Click OK. And launch. Okay, it did launch. It didn't leave the pad though, because there wasn't enough thrust. And if I graph it, let's graph it, time, and let's do the thrust curve. In, altitude. And when engine burnout occurs, plot that graph. Okay. So here, see the yellow line right here is my thrust curve, and it should match that thrust curve that we created in Engine Edit, and has a burn time of 0.1 seconds and reaches a peak thrust of 0.015-ish newtons. And the rocket, it just didn't have any amount of thrust to get it off the pad. So our fake motor is working. So that was what I wanted to just demonstrate. Okay, so now we need to create a rocket that's going to have these flyaway rail guides on it. So creating a flyaway rail guide. So let's take this rocket right here and go to the design components. And the flyaway rail guide is going to be a pod attached to the outside of the rocket somewhere, just like you saw here on this rocket. So it could be anywhere. It could be at the bottom tube, it could be at the top tube. We'll put it on the bottom tube just like this one here. Okay. So we actually want to, not that tube, we want this tube right here. Come on. This tube. Okay, so that tube is highlighted, and now we're going to add a pod to that tube right there. So here's a pod. We added the pod. We're going to change the location. We're going to slide it here. You see it's right there. This little symbol right here is just a generic symbol, just so that it has, we can tell where the front of this pod is, because the pod is a placeholder. We're adding other parts to it. So now, trying to model a pod, a flyaway rail guide that looks like that, that's going to take a little bit of time. So I'm going to cheat. I'm just going to create a tube that goes around my my rocket that has a little bit of drag. That's all we want this to do, is to simulate the weight and the drag of this item. Okay, so, and I'm going to say that this pod can be ejected. That was the whole purpose of making that fake engine, is so, because the engine controls when it's ejected. So I do that, and it put the pod right there, and now we can start attaching parts to this pod. So I know I need at least one part in this pod, and that's a tube that I can put my rocket engine in, my fake rocket engine. So I'm going to add a body tube to this pod, and it's going to be a 13 millimeter because I made a 13 millimeter fake motor. So click OK, and you can see it added it right there. The color is gray. That's like terrible color. Let's change it to that color there. So here is this tube, and now we are going to adjust the length of that tube. And I really don't care too much what the shape looks like. I'm just trying to simulate the drag and the weight. So as long as this pod adds drag and adds weight, I'm okay. I'm happy. And I know I'm going to add weight, and if it doesn't add weight, I'll just throw a mass object on it. But it should have this amount of weight right now. So does a body tube affect the drag? And a little bit. But the thing that we're more concerned about is the weight. Because it's going to fall off the rocket so fast that the drag isn't going to matter that much. But the weight might matter. So I'm gonna do a mass override here on this pod, and I'm gonna make it like 5 grams. And the position, that CG position, is from the front of this tube. And I forgot how long I made that tube, 1.6 inches. So half of 1.6 is 0.8 something. I'll call it 0.82. So now that mass override is turned on, and if you, so here's our current mass. Okay, so when this mass falls off, this weight should go down. So I'm going to click OK here. Okay, so here is my flyaway rail guide, simulated flyaway rail guide. and I want to put this in 2D. So here's the current mass right here. And if I go to the pod, and okay, so here's the mass right here. Watch this number right here. When I click mark this pod as ejected, it's going to like take that pod and just pop it right off the rocket. So that pod should go down by 5 grams. So it should go down to 42 grams when I check it. And that's correct. It does fall off. So now we have the pod on there, and we can load a rocket engine into this pod. So I'm going to go to my simulations. Okay, so I'm not seeing it here, so what happened? I forgot to mark that tube as an engine mount tube. So this body tube, I need to mark that as a motor mount tube so I can put an engine in it. And let me call this the Flyaway Rail Guide. Change the name of it. Okay, so we can load an engine in it. I'm going to load an engine. I'm going to load my fake engine in it. Okay, so watch this mass right here. So we got 47.081. Now, I made the mass of the motor 0.002 grams. So this mass, when I click the OK button, should go up to 47.083. Sure enough, it worked. I have now accounted for the mass of the motor, that new mass, and it didn't go up hardly anything. So the mass of the Flyaway Rail Guide is 5 grams. The mass of the fake engine is 0.002 grams. So the total that I've added is 5.002. So now if in real life, if I actually measured my rail guide, I would subtract off that 0.002 grams, and that would give me then I'd match the actual weight of the Flyaway Rail Guide. Okay, so that is loaded. And so I'm going to go prepare for launch again. Okay, so we have the fake one there, and then this one, choose engine. We'll do an A3. I'm going to make it a custom. I'm going to make it 6 seconds just to see what happens. Click use and OK. So here's the Flyaway Rail Guide is in the red one. I got these backwards. See, with the Flyaway Rail Guide is this tube right here. That one should have the fake motor in it, and the one in the middle should have the Estes A3 motor. So I got to change those around. A3 custom 6 seconds. Use OK, and then in this one we want our fake motor with a burn time of 0.1 seconds. Click OK. Okay, so now we have it in the rocket. We're going to deploy at maximum ejection delay. And we're going to launch it straight up, 36-inch launch rod. Launch conditions, 8-mile-an-hour wind. Okay, so we're going to launch it. And it did the launch. Okay, so now, how do we prove that the Flyaway Rail Guide fell off at the right time? You're not going to see it in the 2D flight profile because it doesn't show things falling off. But you can see it when you look at the graphs. So I'm going to graph this data here. So the x-axis will be time, the y-axis will be thrust. I want to graph the mass of the rocket right here. And yeah, let's just graph that for now, and let's make thrust red so we can see it a little bit better. Okay, so here's our graph. Okay, so here's the mass. it didn't fall off. See, what I'm looking for is on this green graph right here. At 0.1 seconds, which would be right here, I should see a 5-gram drop in mass. So going from about 54 down to, you know, under 50 grams when that pod drops off. It didn't drop off. So I'm thinking, why didn't it drop off? Because I forgot to tell it to drop the pod off. So let's go back here to prepare for launch, and I need to go under, see, I had it dropping off at 6 seconds. It should have been at 0 seconds. Oops, nope, not that one, this one. The fake engine should have dropped off at 0 seconds. So at 0 seconds, the ejection charge kicks, and that kicks the pod off. All right, okay, so if I make that change, I think it should work this time. Look what happened here. The first time I launched it at 199.97 feet. The second time I launched it, I went 241 feet. So something happened there. And what happened was we lost 5 grams. So if I look at this, I should now see, yeah, now I'm seeing it. So like I said before, if we look at the mass, which is this axis right here, is about, you know, 54.5 grams, and we drop at 0.1 seconds when the pod falls off. When the motor burns out, the pod falls off, we lose 5 grams, which is the green line. So it dropped here to, like, you know, 48.9 grams. And then the motor continued to burn. The A3 in the middle continued to burn until it burned out. So this is the A3 motor burning right there. It's just burning off propellant like normal. But this big drop is the pod falling off. So I know it worked. And when we lost the pod, we lost, you know, the drag also went down. I don't know how much the drag went down. Let's see if we can figure it out. Let's plot that again. See if we can plot coefficient of drag. I'm going to get rid of the thrust here and make the thrust total drag. So we have total drag is red and the CD is black. Let's make it blue. And plot that graph. Okay, so nothing. Our CD is blue. The total drag, yeah, see, nothing really happened till about 0.2 seconds. So why? So this is a question. Why at 0.2 seconds did our drag force change? I got an idea. I think I know. Let's also plot altitude. So what happens at 0.2 seconds? So we got altitude, and that will be black. So plot graph. Okay, altitude is black. So okay, so altitude here is in feet. Okay, so here's 10 feet. What was the length of our launch rod? Was it 3 feet? So 3 feet, is kind of about, let's see, 2, 4, 6, 8, yeah, so each of these divisions is 2 feet. So 3 feet is like right where the thumb is on my pointer. So if I come across here to about there, 3 feet, at 3 feet, that's when the rocket leaves the rod. So at 3 feet, the rocket becomes unrestrained. So so what happens is the rocket, as soon as it hits the top of the rod, as soon as it clears the rod, a gust of wind is hitting it. You know, we had it set at 8 miles an hour. At 8 miles an hour, all of a sudden, now we're instantly at an angle of attack. And so that's why the drag and the coefficient of drag jumped way up, because now the rocket, instead of the wind coming straight down from the top, we got a little bit of side wind, and that causes an angle of attack, which means that we have more surface area on the rocket as it's going up. More surface area means more drag. So that's why our drag had this big spike right there. It wasn't much, but you know, you can see the coefficient of drag change. But nothing really happened here on the launch rod, because I think I made my flyaway rail guide fall off too soon. You know, because it takes like to 0.2 something seconds, like 0.225 seconds for it to clear the launch rod. So my flyaway rail guide is actually falling off too early. I should have made the thrust duration like 0.3 seconds. So that was a very long-winded explanation of how to create extra drag that falls off your rocket at a specific time. You could use that. So I can make drag fall off the rocket. I can't add drag to the rocket. That's the other thing. This is what Karen Ma was asking about last time, was, you know, if I have drag brakes on my rocket, how do I add them? And the answer is you got to deploy a parachute, where decreasing drag off of a rocket you got to do with a pod that falls off. So it's two different ways to do two different things. And this is really advanced. This is a really good topic for this particular RockSim Live, because otherwise we never talk about doing these advanced things. So thank you, Ron. I hope that answered your question. It was very long, very convoluted, but I had a lot of fun. Nick writes in the comments, any idea when you will have more fiberglass nose cones again, 40 millimeter size? We've never had a 40 millimeter size nose cone. We had a 38, but not a 40 millimeter. And the answer is we don't make them. So I have a standard answer that I give people. And it's, when will things be back in stock? And let's go to shipping info, shipping information. Well, it's like, I think if I go to, he wants a fiberglass nose cone, so he wants to go to building supplies. Building supplies right here. I go to nose cones, fiberglass parts, nose cones. We have 0 nose cones in stock. Body tubes. Okay, so more info on that body tube. That is out of stock. And if you come here to sold out, and there's a thing that says, when will it be back in stock? And this is his question right here. When will it be back in stock? So I click on that, and it's going to take you to this page. And I want you to watch this video, because I had a lot of fun making it, because this is like the most commonly asked question that we ever get, is when is it going to be back in stock? And the answer is, watch the video. It's a lot of fun. So go there, watch the video. Let's move on. Joseph Dunning says, is there a way to simulate 2 parachutes? I tried adding a second one to a booster so both would deploy at 600 feet. The simulator didn't deploy any main chutes. Okay, so he wants to do, this is not exactly dual deployment, because dual deployment is two chutes at 2 separate times. He wants to deploy them both at the same time. And RockSim, it has to make a choice when it sees 2 parachutes at the same time, is which one to deploy. And it should always pick the larger of the parachutes, because if you have a big parachute and a little parachute, it's the big parachute that affects the flight. The little parachute, a lot of times, it will just fall flat, just kind of go limp. And you know, if you've ever flown a dual deployment rocket and both parachutes are like really close together, you'll see the pilot chute or the drogue chute just hanging limp. So if you want to do dual deployment, let me open up a different rocket here. Aerotech initiator. Everybody knows what the Aerotech initiator looks like. Do I want to save that? No. This one has one parachute right there, and we're going to add a second parachute. So there's the first parachute, and I'm going to, putting into that body tube right here, I'm going to add another parachute. And this one, let's see, does he say what size? Simulate a second one so that both would deploy. He doesn't say what size. I'm going to go to the database, which is right here, and we'll just choose a 12-inch nylon parachute. Click OK. And right now it's right there. I'm just going to move it. Oops. I changed the diameter. 12-inch. I wanted to move the location. Okay, so here's the location of the second parachute. Click OK. So now we have two parachutes. I should change the name of it. Let's call this one the smaller one. Smaller parachute, so we can tell them apart. So this one is, what did I say, 12 inches, and this other one was 22 inches. Let's make this one bigger. 32 inches. Click OK. So now we're going to do a launch. Choose an engine. It doesn't matter which one. Click OK. Okay, so now in the flight events, we have two parachutes. When are they going to be deployed? So, so this is the bigger one. Let's deploy that one at Apogee, and let's deploy the smaller one. Let's say the smaller one, don't deploy this one at all. So this is just for reference. So the first one is just going to deploy the big parachute. And let's launch it. Okay, so we've got this rocket, and it came down, let's say time. I'm looking for total flight time. So I'm going to do an organized column. So I did a right click on the top bar right here, and you get organized columns. And then you can say what you want to display. And I want to display total flight time. Let's see, do we have a descent speed? No. Altitude at deployment, velocity at launch, guide departure. Okay. Okay, so our first one, this first one that we did, had a total time of 34.7 seconds. And the landing speed, so I double clicked on that simulation. The landing speed, perishable velocity, deployment, altitude, okay, landing data. Velocity at landing right here. Vertical velocity of 12.68 miles per hour. So that was with one parachute. So now let's run it with two parachutes popped out and see if this number right here changes. So rerunning the simulation, flight event. So we'll also deploy this one at Apogee and launch. Okay, so here's the two simulations, and I can see by the total flight time, nothing has changed. With that extra parachute open besides the big one, you know, it's the big one that determines everything. So let's look at the velocity at landing, 12.68 miles per hour. So it's the same. So like what I said, when there's two parachutes that come out at the same time, it's going to choose the larger one as the one to calculate the descent rate. So now if your question is, okay, if I have two parachutes and I want them both of the same diameter, but I do want them kind of like a cluster of parachutes. You know, like when the Apollo came down, it had a cluster of 3 parachutes. And I think SpaceX Dragon also uses 3 parachutes. So what do you do in that case? The answer to that is you got to trick RockSim by making one parachute equal the same diameter as 3 parachutes. And this is a little bit harder. So you're going to go to your parachute right here. So this parachute, and right now this one is 32 inches. So say we had 2 16-inch parachutes in a cluster. So we already know that it's only going to deploy 1 parachute. So so the trick is that we've got to take our 1 parachute and make it bigger to simulate the effect of a cluster of 2 parachutes. So now we need to calculate the areas of parachutes. And this is where it gets a little bit harder, because we're going to calculate area. So if I make a 4-sided parachute, I can trick it easier, because a 4-sided parachute is just a square, and I can find the area of a square pretty easy. I just take the length times the height. So if both are the same, so if 1 parachute is 10 inches square, our total area is 100 square inches. Pretty easy. So if I double that, now I got 2 parachutes with a total area of 200 square inches, but I got to take that and make it into a 1 parachute system. So I need to take the square root of 200, and that's going to give me the length of each side. So this is where it gets a little convoluted. So let me go to a calculator, and I'm going to put 200, and I'm going to find the square root. So square root, 14.14 inches. So on a 4-sided parachute, I'm going to put 14.14 inches as the length. So this will simulate a cluster of 2 parachutes that are square, where each of them is 10 inches on a side. So if you have a different shape, it's the same process. You got to calculate the area of each chute, add them together, and then do some geometry to figure out what the equivalent of 1 parachute would be for that system. And that's how you would calculate it. It's a little bit harder. And to make matters worse, 2 parachutes have a different coefficient of drag than 1 parachute. I don't know if you recall seeing, let's see, let's go to an Apogee parachute. See if I got a photograph so I can show you what's going on. Building supplies, parachutes. And I want to go, let's go larger than 24, and let's do this one right here. And it's not that I want to see that one picture, I want to see this picture right here. Let's see if I can make this bigger. Yeah. See, what happens is those parachutes are kind of tilted just a little bit as they're coming down. So instead of getting the full amount of drag by coming down perfectly horizontal, they're tilted a little bit to the side, and so their drag actually goes down a little bit when you have a cluster, because they kind of splay out. So not only does you have to calculate an area, but your coefficient of drag is also going to change, and it's going to go down a little bit. The question is, how much does it go down? And I don't have, an answer right off the top of my head. You got to do an experiment. And For this experiment, you got to go revisit our topic from last week on how to calculate the coefficient of drag of a rocket, because we're doing the exact same thing with the rocket coming down. It's easier with the rocket coming down than going up. But you have to calculate the coefficient of drag. So go back to how-to and guides, software, RockSim live training from episode 41, right here at the 42-minute mark, is how to calculate the coefficient of drag of a rocket. So you're going to do this with 2 parachutes and see what happens. I just thought of another resource, how-to and guides, educational, maybe technical information. Okay, under technical information, go down here to R&D project from the NAR, click on that, and in here, my daughter did this exact experiment of doing cluster parachutes. Okay, so right down here, comparison of the number of parachutes versus descent rate. And it's a PDF, and this is done by my daughter, and she did it 11 years ago already. See, you got a single parachute, and then you got 2 parachutes, and then you have 3 parachutes. And she tried to measure the descent rate differences of this very situation. And I'll let you read that report because, like, we're out of time. And Joseph Dunning says, can this be fixed in the next update? And Joseph, there's nothing wrong, so there's nothing to fix. It's just a matter of, you got to know the coefficient of drag. And I don't know what the coefficient of drag is. I could guess, but you want accuracy, and I can't give you accuracy because everything is going to depend on the shape of the parachute you use, whether it's an octagon or a circle or a hexagon, the fabric that you use, the length of the shroud lines that you use. All that makes a big, big difference for calculating the coefficient of drag. We are out of time, but Mark Sell has a question. I was trying to add an ARR nose cone to a design, and RockSim would crash continuously before I could finish. What am I doing wrong? You're letting RockSim crash. I have no, if RockSim's crashing, I don't know what's going on. It's something that we'd have to debug. If it happens over and over and other people can duplicate it, then it's fixable. But if other people can't duplicate it, then it's a lot harder to fix. So that's the answer to that. So we got to end because we're out of time. We've gone well over an hour as usual. We will be back next Friday at 2 p.m. Mountain Standard Time, which is 4 p.m. on the East Coast. If you would like to try out RockSim, it's apogeerockets.com/RockSim. If you'd like to try out our launch visualizer, which is 3-dimensional flight simulations, which is so cool. I haven't demonstrated it in several weeks, and I'm just itching to try it out because every time I try it out, there's more and more cool things that I see. So try that out, rocksim.com. Go ahead and just try it out. And if you'd like to access all the features, send me an email through the contact form, and I can activate all the features for you. I can turn you from a basic member into a premium member. Premium members have more features available. And right now we're not charging for it, so I'm giving that away for free right now, just so I can get input from beta testers on what they think and, are you discovering any issues? That's what we're doing in beta testing, is fixing issues. We're not adding any new features right now. Our feature list is flat. You can say, oh, I wish it did this. That's a feature. We're not adding any new features, but we will fix things that are broken. And I found one the other day that's I hadn't seen before, so the programmers are working on that. All right, so I got to end this. It's just like we're going to launch a rocket. I'm going to do a countdown, and then I'm going to click the end stream button. So ending the stream in 5, 4, 3, 2, 1. Go out and launch something.